So after Harry Hess made this pretty great discovery, right, that the ocean floor was definitely in motion, that led people to go back and take a look at Wagner's work. And so what people were able to do then was to take what Harry Hess had mentioned, combine that with what Wagner had said, and come up with a bigger idea. That bigger idea being plate tectonics, right? That both the ocean and the continents are in motion. So now let's wrap up those two separate ideas and let's combine them together and take a look at what plate tectonics is. So, when we talk about a tectonic plate, we're talking about the lithosphere. So if you remember back from the last chapter, the lithosphere is composed of both the crust and the upper mantle. So basically what we're doing is we're taking a look at the interaction between the asthenosphere and the lithosphere. Remember, the lithosphere is rigid and solid, and the asthenosphere is partially molten and can flow. So what's happening, right, is that our lithosphere is moving over the asthenosphere. And it's that interaction between the two that's going to give us plate motion. So, the other thing we have to take a look at is not just this side-to-side motion, but the lithosphere also moves up and down. Okay, so before I mention here how it's working on the lithosphere, let's talk about an example first. So let's say you were to take a look at a boat on the Mississippi River. Let's say that boat is loaded down with 500 tons of cargo. That boat is going to start to sink. Right? It's going to be physically sitting lower, right, on the river, right, than an empty boat. Now, let's say I take 300 tons of that cargo off. Well, that boat is now going to rise back upwards. So that up and down motion is the same thing that our plates do. So when our plate is loaded with weight, meaning think about, say, mountains, right? They're much heavier and thicker. Or an area that might have a glacier on it is heavier and thicker. It's going to physically push down that lithosphere. It's sitting like that heavy boat. So when the lithosphere is pushing down on the asthenosphere, it's going to cause the asthenosphere to move. This is what we call the principle of buoyancy, or in science we call it isostacy. So basically, like I said, right, we can have that up and down motion based on weight. So if you again start thinking of this stuff like fluids, right, it's really going to kind of help you realize what's going on. So, right, we can take a look at this in relation to, say, an iceberg. So an iceberg, right, if you were to take a look at it, right, some of it's sitting on top of the water, some of it's sitting in below. But I want you to notice here that there's two lines on the ocean. You've got this top line and then this darker line. That darker line is where the water line was before the iceberg fell into the water. Once that iceberg fell into the water, the whole water table rose. You've noticed this, right? If you have a glass of water and say you put an ice cube in it, well, now the water is sitting higher in your glass. That's because you have displaced water, right? The same thing happens with our crust. Our continental plate physically floats higher because it's lighter, right? It's not heavy. Our ocean crust physically sinks lower because it's heavier, so it's actually displacing more of that asthenosphere. So if we take a look at plate motion, we have three basic boundaries. And we have three boundaries because our Earth is round. If our Earth wasn't round, if it was flat, our plates would only move in two directions, but thank goodness Christopher Columbus showed us that the Earth is round. So the first type of motion we can have, and we're going to get into this more when I come back next week, is divergent boundaries. The divergent boundaries where my plates are moving apart from each other. Right? This is what's happening at the ridge. This is what we talked about, right? What Harry Hess noticed. So here we've got our plates moving apart from each other. Then we have our convergent boundaries, right? This is what's happening at the trench. Our plates are crashing into each other. And we're going to see as we get into this, some pretty cool things happen here as we get this collision. Right? You get this nice trench, you get lots of volcanoes, lots of earthquakes, all sorts of really neat things that happen at that convergent boundary. And the last type is our transform boundary. Because we live on a sphere, we have to have sliding motion. I want you to think about this. If I have an egg, right, can I ever crack that egg with a flat line? Well, the answer would be no, right? If you look at it, if you look at an eggshell and you break it, you would notice that it kind of breaks like this, right, with that stair-step pattern. Okay, that's because we have sliding motion. Okay, so the Earth cracks the same way. So what we actually have is remember we talked about our ridges, right? That's where our divergent boundary is happening, right, with our plates moving away from each other, and they're offset. We talked about those offsets. Those offsets are the transform boundaries. That's where we get sliding. So we're not creating or destroying crust here, it's merely sliding. And it's sliding because we live on a sphere. So when I come back next week, we're going to take a look very specifically at each one of these boundaries and determine what we can physically see in these boundaries.